swear, I spend more time looking for the parts I need than actually building anything. Hey, what's happening, guys? In our last video, we used an op amp, a TL072, as a gain stage in an oscillator. Today we're going to use a different op amp, the LM386, as what it's intended for, an audio amp. So I don't know if this exactly fits into the classic circuits you should know mold, but we're going to show you how to set up an LM386. Super easy, using its internal gain to make yourself a basic little audio amplifier. So the first thing we need to do that is we need an audio source. I got all kinds of options for audio sources, but I like to keep things simple. And if you've been watching the channel for a while, you know my favorite IC of all time is the 555 timer. So I have set up here a simple bistable 555 timer. I'm sorry, astable 555 timer. And it is oscillating at about 1 kilohertz, which we can take a look at here. The 555 timer, as you know, outputs a square wave. But square waves don't sound good, and, you know, frankly, they're not good for speakers. They're not really audio. They're actually digital. But what I've done here is I simply set up a low-pass filter. These are 150 ohm resistors, 1 microfarad capacitors, 3 stages. Should give us an approximation of a sine wave. No, we're not going to look at it on the scope, because you know what? Very few people actually have scopes, and I want everybody to know that they can do these kinds of projects and experiments at home. You don't have to have a scope. There's other ways. So we're going to use this cheap Zotex ZT M0 auto manual meter in frequency mode. And if we come up here and we put her on pin 3, you see we get 1.075 kilohertz. Close enough to 1 kilohertz for government work. And after our filter, well, that's showing 16 hertz, but that's not true. That's just because the voltage is so low. So you're not getting anything there at all. Yeah, don't worry. We're still getting it, and I'll show you that as well, again, without the use of a scope. All we need is a speaker. So we'll plug the negative lead of the speaker into our negative rail, and we'll touch it to pin 3, and you can hear the 1 kilohertz tone. We'll touch it here after the first stage. It's much quieter, more of a sawtooth, smoother. It's a triangle wave there. And now, this is going to be extremely quiet. I don't know if you're going to be able to hear it or not, but there is sound there. So listen carefully, and you should be able to barely hear the sine wave. Try and get this up as close to the camera as I can. Here we go. There we go. So that's our sine wave, but the amplitude has been limited by our low pass filter. So what we want to do is we want to amplify it. We're going to use an LM386 audio amplifier. Let's bebop over to the computer and have a look at the data sheet. Alright, so here's the data sheet for our LM386 low voltage audio power amplifier. And we have it in the 8-pin DIP package. And there's some information that tells you it works on battery operation with minimum external parts, and that's the truth. And a supply voltage of 4 to 12 volts, which is excellent. We're going to be using that. It has low quiescent current drain. That means when it's not active, that's your gain. Now, your voltage gain here from 20 to 200 Ours is going to be 20, which is the built-in internal gain, okay? And then we have some applications here. What's ours going to be? Portable tape, TV sound, line drivers. Yeah, just a small audio amplifier. I guess they don't list that. And here you can see the schematic of how it's built. And if you take a look here, I mean, what is it made up of? I know, you're all yelling, it's made up of transistors. I know, but check out how many transistors are in here. Did I get them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 transistors. 1, 2, possibly 3 diodes? Is that a diode? That's strange. 1, 2, 3, 4, 5, 6, 7 resistors. So, I mean, that's pretty cool. There's a lot of stuff there. Come down here and you get your basic information. There is our pin out. Input minus, input plus, ground, bypass, blah, blah, blah. Tells you what your pins are here. Inverting input, non-inverting input, absolute maximum. But we're going to roll on down here to the application circuit. Typical application. This is the LM386 with an internal gain of 20. And this is what we are going to set up here today. Just super simple. We're going to put it together and we are going to make it work. Now you see this will be a non-inverting amplifier because the inverting pin is grounded. Then we have a volume control here on the non-inverting pin. Other than that, we have a nice big DC blocking capacitor going to our speaker. A little filtering going on here. And that's all she wrote. Let's do it. Okay, I think we're ready to go and get started. You can see we have our circuit diagram here. And there are 3 pins we will not be connecting, 1, 8, and 7. 1 and 8 are where you can connect, I believe it's a capacitor for external gain. And then 7 is a bypass that we're not going to be using either. So we shall bring in our circuit and avail ourselves a lovely LM386. Who will it be? Who will it be? Who will it be? Who wants to come out and play? You? Okay. So you know ICs always have splayed legs. They make tools for this, but hey, we don't like tools. Just put them on your bench, give them a little bendy bendino, and you're good. We'll put him way over here. Alright, so let's start by hooking up our power supply. That's the Pittsburgh way to say power. Power. Like former Steelers coach Bill Cowher. Car. We got some nice breadboard jumpers. The reds are too long, so we'll go with an orange. And that's pin 6. 1, 2, 3, 4, 5. This is pin 6 right here. So pin 6 goes to power. Nice. Pin 4 is our ground. We use gray for ground. Just want to make sure that you're hooking your pins up correctly. That's why an old guy like me has one of these doohickeys on his head. Okay, so that's pin 4. That's that. Pin 8 is our output. So let's grab a longish connector. We'll go from pin 8 over to here. Then we need a 0.05 microfarad. Why would you say 0.05 microfarad? Why would you do that? Because now you got to make me do internal head math. It's 50 nanofarads, I think. I'm sure somebody will correct me if I'm wrong. I probably don't have 50 nanofarad, but I probably have 47 nanofarad. And you know what they say, close enough for government work. Unless, of course, you work for NASA, in which case you should probably use the specified value. There is no reason that I'm going this way. You could go that way. It would be just fine. And now it says we need a resistor to ground. 10. 10 what? Well, since they put a K over here, we'll just assume that's 10 ohms. So let's see if we got a 10 ohm. There's 15. There's 1. We could twist 10 of them together if nothing else happens. 100. 10R. Yeah. Good enough for government work. Get that guy out of there. No reason to have 3-foot long leads, so we'll just trim them a little bit. And there is our 10 ohm resistor to ground. Get in there. Come on. Alright, 10 ohm resistor to ground. Next, we need a largish capacitor. We're going to use an electrolytic. 250 microfarads. Well, I got 220. 220 or 330. Let's go 330. When you're doing capacitors, you should always err on the size of caution. 330. Capacitors, of course, long leg positive, but I like to trim mine to the same length because that's how I roll. And that guy will go there like that. Yeah, nice. Okay, pin 2, which is our inverting input, also needs to go to ground. I'm looking for another gray one here. Come on. My fingers are far too large to reach in there without some manner of assistance. So pin 2. One, 2, 2 and 4, 4, 2, both going to ground. Okay. Okay, there's our first mistake. That's pin 8. Our output is, in fact, pin 5. I know. Some of you guys are sitting there screaming at me. You put it in the wrong hole. Not like I haven't heard that before. Only when golfing, of course. Okay, let's try this again here. Pin 5, that's much better. And make sure, yep, going in the right direction there. So next we need a 10K pot. I have a 10K pot right here. So we can get her to plug in nice and neat like. Yeah, success. That is, okay, yeah. That is fully on. That's off. So hopefully we'll put it about halfway to start out with. So the middle pin, our wiper, needs to go to pin 3. One, two, three. Oh, look at that. I almost got it right. The story of my life. Okay. And this one needs to go to ground. Ay, caramba, gotta find another gray ground pin in here. Hey, we got lucky. These cheap breadboards sometimes just require a little massaging to get them to go in right. Definitely want to make sure you have them seated properly. And then this one is our connection over. So, I'm trying to see if I have something of the proper length. No, not really. So what we'll do, we'll take one of these longer gray ones here. And we'll just give it the old benderoony. Just like that. Now, assuming that I put everything together properly, we should be good to go. Oh, we must hook up our sprecher. Sprechen Sie Electronics? The negative, the positive, and the power. I'm putting about 5.5 volts in from my bench power supply. What do you think? Will she make noise or will she go kablooey? Only one way to find out. Okay, 7, 8, and 1 are not connected. Everything else is connected. And we have no sound. Wiper, pin 3. Pin 6 goes positive. Not getting warm. That goes there. Alright, let's make sure we are still oscillating. Now, why is that showing me 50 hertz? Hold on or something? What is going on here? Well, first problem was I had it on square wave out and not hertz in. So yeah, we are still getting our oscillation. Good. But why are we not getting an output to the speaker? What have we done wrong? Alright, I'm going to shut off the power here. And shut that off. Alright, let's have a think. Alright, pin 1. Not connected. Pin 2 connected to ground. Pin 3 to the wiper. 1, 2, 3. Pin 4, 1, 2, 3, 4 to ground. Pin 5 is our output, which goes to our blocking cap and also to this filter. Pin 6 is our voltage supply. 7 is not connected. 8 is not connected. Alright, turn the power back on. I'm going to put this guy over here. Set for 6 volts DC. Let's see that we are getting at the pins. 5.62, and our power supply is showing 5.62, so that's good. Alright, let's look at 6 volts AC and see what we're getting out. Yeah, we're getting oscillation out. As you can see, it's hard to do and not block the camera at the same time. Well, we were getting it. Why are we not getting it now? Try and put it here and here. No. All right, let's disconnect the speaker. Yeah. Let me see. All right. We're getting DC out. This should actually be blocking DC, so shouldn't get anything at all here. We've got an offset here because this is actually a DC. Alright, just for S and G's, let's take out our blocking capacitor. But yeah, if it's blocking all of the DC, we're not going to hear anything. So let's see what we get now if we turn it on. Still nothing. Let's have a look here. Yeah, I'm seeing 2.5. To the datasheet, Robin. So unfortunately the datasheet didn't give me any clues. It's not on right now. Unless that pot's bad. Resistance. 10K pots. We'll put it on 60. Reading 0. Reading 8. Close enough for government work. Now let's flip on the power supply again. I'm going to take you out of here so you can see. Oh. Do you hear that? Do you hear it? Appears to be working. Turn it up. Well, ain't that a miracle? Alright, boys and girls, I have no explanation of why it didn't work before, but now it works. Anyway, the whole point of this was to show you how to set up the LM386 audio amplifier. We set it up as prescribed in the manual for the internal 20 times gain. And after, I don't know, a couple failed attempts, it just decided to start working. I don't get it. But whatever, sure works. So, if you enjoyed this, give me a thumbs up. If you're as confused as I am at this point, give me a thumbs up. Give me 2 thumbs up. Sometimes life's just a mystery. That's it. I'm out. Peace. I want to thank you all for watching and spending time with me today. A community like this is something that we can all be very proud of. So again, thank you very much for all your support of Learn Electronics. Please feel free to check out the Patreon page. $1 a month is all I ask, and really helps keep the channel alive. We also have an Amazon shop where you can buy most of the items that you see on here, and there's a link to it down below.